8th grade math test 19 study guide. So let's take a look at these problems. Problem number 1 says that we need to decide which expressions below are equivalent to this expression given. So we got to simplify the expression given first. So I go inside the parentheses and I do x squared times x cubed first. That's when we add the exponents. Then I take, when I have exponent next to exponent like that, or that's called power of power, then I multiply the exponents there, and that's where I get x squared. If I look at example 1, or excuse me, expression 1, x to the 6 times x to the negative 4th, again, when you're multiplying two powers with the same base, copy the base, add the exponent. So that's the same. Example 2, when I do example 2 here, I see I have x to the 10th divided by x to the negative 8th. Well, that's dividing powers with the same base. So that's when I copy the base and subtract. I go top minus bottom. And since the bottom is a negative exponent, you have to have two negatives there. When we do our rule for subtraction, that becomes 10 plus 8. That's x to the 18th. That's not the same as our given expression in the problem. So we go to expression 3, where I have x squared times x squared over x squared. I do the top part first. X squared times x squared, again, add the exponents, and here, again, subtract the exponents, and I see I have the same thing there, so we go to expression 4, and expression 4 says this: we have 1 over x to the 2nd power for expression 4, but that's on the bottom. This one's not on the bottom. So if I were to write that just out to the side, that would be x to the negative 2nd, because remember, negative exponent means to flip it, right? So that's not the same, so the expressions are 1 and 3. Problem number 2 says which range contains the value of this expression right here. So we have to go inside the radical, or the square root, and simplify that radicand, or number inside a square root. So if I go 130 plus 7 plus negative 20, right, I did the rule for subtraction there, I can use teams. I have 137 positives, I have 20 negatives. Opposite teams mean subtracts. There are more positives than negatives, so inside the square root I have the square root of 117, or rad 117. So I look at the two perfect squares that surround 117. 10 times 10 is 100, 11 times 11 is 121. So 117 is in between those two perfect squares, which means it's in between 10 and 11. So I got to see which one it's closer to. Is it closer to 10 or is it closer to 11? So I subtract these two. 117 times 100, it's 17 units away from this perfect square. It is 4 units away from this perfect square. It's closer to this perfect square, which means it's closer to 11, because the square root of 121 is 11. So this is about 11, is what we found. Number 3 says about how many times more. Well, that magic word about means I get to round, and how many times more is a division problem. So if I go here and I take the larger one, larger meaning exponent, right? Don't worry about coefficient. Larger, you look at the exponent. So I go, that's basically 10, and that's basically 2. 10 divided by 2 is 5, and 10 to the 33rd power divided by 10 to the 30th, like we said earlier, dividing powers with the same base, copy the base, subtract the exponent, there's your answer. Now, sometimes we have to convert that, so that's really about 5,000 times, but when we look at our answers on the test, or in this case on your study guide, you see that they left it in scientific notation. I left it in scientific notation this time, so the answer is 5 times 10 to the 3rd power. Number 4, we have an equation. We want to find the value for g that makes it true. In other words, we got to solve this, so we do the rule for subtraction. Add the opposite, add the opposite. We're supposed to distribute and combine like terms, but I don't have to distribute, so I just go straight to combine like terms. 4g and g are like terms. That equals 5g. Negative 5 and negative 8, those are like terms. That equals negative 13. Now we're supposed to get our variables on one side, but we don't have variables on this right side, so we go to step 3. Isolate the variable. We work farthest away from the variable first, doing inverse operations. We got to do it to both sides, not 2 times to one side. That crosses out the 13. How do I undo 5 times g? Well, the inverse of 5 times is divide by 5, so I draw a line, divide both sides by 5, and I see that the value that makes this true is 15. In other words, the solution for this is 15. Number 5, we have another equation, and it looks like we're solving this one as well. So what I'm going to do is my rule for subtraction first. Okay, so I do add the opposite here, add the opposite here. Don't need to do it there, even though it's minus, because it's not a subtraction problem. It's just a negative number. Now I distribute 1/3. Distributing 1/3 is like dividing by 3, right? So I go 1/3 times 6x and 1/3 times -3. 1/3 times 6x is 2x. 1/3 times -3 is -1, right? Positive times negative is negative, Mr. Dude, right? So now here I have, I distributed, so those brackets go away, and I can combine like terms. I don't think inverse operations like I did in that last problem, right? I only do inverse operations when I'm moving stuff. If I'm not moving stuff, in other words, they're on the same side already, I don't do inverse, I just treat them the way they are. So I add a -5 to a positive 2x, and that equals -3x. And now I can go to step 3, since I don't have variables on the right side. Step 3 means isolate our variables, so I work farthest away, add 1, divide by -3. Negative divided by negative is positive. 66 divided by 3 is 22. The solution is 22. Number 6, we're going to pick all of the equations that have infinitely many solutions. Well, infinitely many solutions means this. First, you have to simplify both sides. That means distribute, combine like terms. After you do that, you look at both sides. If you have the same coefficient and the same constant on both sides, it's infinitely many solutions. You don't even need to solve that. You can stop right there and make a decision. Equation 1, we have to distribute and combine like terms. Left side is already simplified. Right side, I distribute that -1. You see I did the rule for subtraction. Minus side outside parentheses means distributing a -1 or taking the opposite of everything in there. So I distribute. I get -x plus 10 on the left, -x plus 5. I have the same coefficients, but I don't have the same constants. So this is what we would call no solution. We need to know that, right? Because different test questions will ask for no solution or one solution. We're looking for infinitely many this time, but read the directions because it always changes. So that one's no solution. That's not part of our answer. Equation 2 we go to now. Equation 2. I'm going to do my rule for subtraction and then distribute. So 3 times 2x is 6x. 3 times 2 is 6. Minus 12 is the same as plus -12 over here. 4x plus, I write that down, then I distribute that -1, right? That's what I said earlier. Minus sign outside parentheses means distribute a -1. -1 times 6 is -6. -1 times -2x is positive 2x. Negative times negative is positive. Combine your like terms. I combine the two constants here. I combine the two coefficients here because they're both x's. And I see I have the same coefficients, same constants. That means same number in front of the letter, same number by itself. That is infinitely many solutions. So part of our answer includes equation 2. Now we check equation 3. Equation 3 again. Rule for subtraction, distribute, combine like terms. 5 and -1 is 4. I don't add the 3x because it's not part of the constant family. It's part of the x family. They're not like terms. Over here on this side, I distributed. This -2x and this positive 2x cross out. Now, if I have different coefficients on both sides, that's always one solution. And different coefficients means this. That means I have an x on one side and no x on the other side. Those are different coefficients. So that's one solution. That's not part of our answer. Equation 4, again, rule for subtraction here, here, and here. Distribute the -8. -8 times x is -8x. -8 times 1 is +8. Copy the rest. Over here, I didn't have to distribute. I did the rule for subtraction here and here. I combined my like terms. I have 3 x's over here, 3 terms that have x's. So I add the 2, the -1, and the -9. I use teams, and I get -8. Then I simplify the left side, combine my two constants, and I see I have the same coefficients, same constants. That's infinitely many, so the answer is equations 2 and 4 have infinitely many solutions. All right, so we're going on to number 7 right now, and number 7 says they give us an equation, and they tell us, ask us which ordered pairs are solutions to that. So what I have to do is I have to take the ordered pair and plug it in. This is x, this is y. So 0 goes where y goes, the slope is 7, and x goes where x goes, and I simplify. That's not true, so that's not a solution. Check the next one. The point is 0, 0. I put y where y goes, x where x goes into this equation. Again, simplify. That's a true equation. I have the same number on both sides. So that point right there is on this graph, or is also known as a solution to that. So 2 is part of our answer. Let's check 3. 3, we have the point 1, 7. I plug y where y goes, x where x goes into this equation again, simplify. That's true, 7 equals 7, so 2 and 3 are both part of our answer, and 4. X is 2, y is 14. I put the y where the y goes, x where the x goes, and I simplify. That's true. So 2, 3, and 4 are all solutions to that equation, or they're all on the graph of that line for that equation. All right, so number 8, we have a graph, and I see right here, if I take one point here and another point way over here, those are on the lattices, right? I couldn't use any of these other points because they're not right where the crosshairs hit. That's called the lattice. So if I get one from one lattice to the other, I count up and over. And by the way, I checked, is this positive or negative? It's going uphill instead of downhill, so it's positive. So I go up 1, 2, 3, and over 1, 2, 3, 4, 5. That's a slope of 3/5. Now I take a look, and it says I'm not trying to pick which of these relationships match this, and that's the mistake, because some of you aren't reading the directions. The directions say which relations located under the graph have a slope that is steeper than this. Sometimes I ask you for a slope that's the same. Sometimes I ask you for steeper. You got to be careful. You got to read the directions every time. Don't ever assume. So this is a slope of 3/5. A slope that would be steeper than 3/5. And again, we don't worry about positive or negative slopes. We just assume it's absolute value. But we're looking for a number that has an absolute value greater than 3/5. That would make it steeper. So in other words, I got to find the slope for all those. So for relation 1, they gave me a table, and in the table I see that there's the coordinates 0, 0, so I know this is proportional, which means I only need 1 point. I put y over x. 4/5, 4/5 is steeper than 3/5 because 4/5 is more than 3/5. Relation 2. Relation 2, they give me a table. This time they don't give me a 0, 0, so I can't take the shortcut. I have to take 2 points, any 2 points I want. I'm going to take these 2 points right here I got from the table, and I go y minus y, 3 minus 1, over x minus x, 5 minus 0, and I get a slope of 2/5. 2/5 is not more than 3/5, so that is not steeper. Relation 3 is a graph, equation that's already in slope-intercept form. The y is isolated. I see that it's linear, so I look what it's in front of x. The coefficient's 1/2. 1/2 is slope. 1/2 is not greater than 3/5, right? Half of 5 is 2.5, so that's not greater. And so I take a look at the last one, relation 4. Relation 4 gives us 2 points. They say a line goes through these 2 points, so I just use those 2 points, and I go y minus y. And if I go right minus left, that's okay as long as I go right minus left on the bottom also. You should have got a slope of positive 2 for that positive video. Make sure you're doing these. And 2 has an absolute value that's greater than 3/5, so that's steeper. So the answer for that is relations 1 and 4 are steeper. Problem number 9, it says read the directions again carefully, because this time I'm asking you select the statement that correctly describes the solution to this system of equations. So we got to make sure we know what it looks like when there's no solution, infinitely many, or one solution. Okay, so the way we do this is we solve this. We already have one of our variables isolated, so we're ready to substitute. We take the one that's isolated, it says y equals, so I put it into the other equation where the y goes. So I'm going to rewrite this equation. I rewrote it here, but instead of putting y, I put this stuff in parentheses, and then I solve. Like we said earlier, solving means do rule for subtraction, distribute. Negative 3 times 3x is 9x, negative 3 times negative 2 is 6. Combine like terms, and 9x and negative 9x are like terms, those combine, but we have a problem. We have a problem because our x is crossed out. When our x is crossed out, there isn't one solution. There's either no solutions or infinitely many. And I look at this and I see that these are different, so that's no solution. If they were the same, it would be infinitely many. If it said x equals a number, then I take that x and I plug it back in here, and I get my x and my y, I get my solution. Number 10 says, one equation is this, and then they give you 4 other equations. And they say, which one of these makes infinitely many solutions? Well, we could do what we just did 4 times. That's too much work. So instead, I'm going to take all these equations and put them in slope-intercept form. The one that is the same equation as this one is the one that has infinitely many solutions, because they're the same line, and they intersect infinitely many times if they're in the same spot. So I take this first one, and I isolate y by subtracting x from both sides. Don't forget that negative. How do I get rid of that? I divide everything by negative 1. And another way to say x minus 4 equals negative 4 is, y equals x plus 4. These are the same line, but this one's in slope-intercept form. So now I have to take all those other equations and put them in slope-intercept form in order to answer this question. Okay? So, where are we at here? I think I'm missing a page, so I'm going to do this one here. Alright, so we're still on 10. And for 10, we're going to check A. And 10, we have 2x minus 2y equals negative 4. So we're going to put this in slope-intercept form. I subtract 2x from both sides. I get negative 2y equals negative 2x minus 4. Now I have to get rid of that negative 2, so I divide everything by a negative 2. Okay, so that becomes y equals negative over negative is positive, negative over negative is positive. That's x plus 2. Well, that's not the same as x plus 4, so that doesn't have infinitely many solutions. Let's do the next one. We're on B now. B is negative 2x plus 2y equals negative 8, so we're going to isolate y. I add 2x to both sides. I got 2y equals 2x minus 8. I can't add those two because one's an x and one's not. Divide everything by 2, and I get y equals, this is 1, right? So that's x, and this is negative over positive is negative 4. Well, that's not the same. That's x plus 4. This one's x minus 4. I don't want that one. Okay. So, going on to the next one now for problem number 10. And C, we have 2x minus 2y equals negative 8. Again, slope-intercept form. Since this is a positive 2x, I'll subtract 2x this time. Negative 2y, don't forget that negative right there. I can't add these two, so I have a negative 2x, and I have a negative 8 or a minus 8. I divide everything by negative 2. Whoops, sorry about that. I got y equals negative divided by negative is positive, negative divided by negative is positive. Now I have the same thing. C is the one that has infinitely many solutions with the given equation. Alright, so now we're on problem number 11. And problem number 11 says, where am I at here? Problem number 11 says, they give you two cell phone companies. And they tell you that cell phone company A charges $135 per month. That's the slope that goes next to x, plus 150 initiation. That's a one-time deal. That's our y-intercept. Now, y is always money, right? X is always time. So the money equals 135 times every month. Month is time, so it's got to be x, plus 150. That's company A. Company B is only 150 a month. So here are our equations. The question is, when are these two, in other words, when means how many months, which means solve for x. When are these two the same? So I set them equal to each other. I use the substitution method to solve this system of equations. I plug that in there. This equals this. Solve for x. Subtract 135x from both sides. Divide by 15. And I see after 10 months they'll be the same. Now number 12, they say which of these is a function. Now for problem number 1, relation number 1 I should say, they have a y squared. Anytime you guys have a y squared or absolute value of y, that's not a function. So if you see y squared or absolute value of y, that equation can't be a function. Okay? Now don't confuse this with linear, right? Linear means regular x, regular y. So, I mean, you could have x squared is still a function. But as far as it being a function, you're looking for y squareds or absolute value of y's. If you have that, no function. Relation 2, they give you a set of points. And in relation 2, I see none of my x's repeat. It doesn't matter if my y's repeat, right? If my x's don't repeat, it is a function. Relation 3, again, none of my x's repeat. That's a function. Relation 4, that's a graph. If I do my vertical line test, 1, 2, it hits it more than once. It fails the vertical line test, so my answer for that is B. Alright, number 13. We're on number 13 now. Number 13 says, they give us a table, right? If I take a look at this table and I have to write the equation for this, and if I see my x's or my inputs over here, my domain is in order, and I know this is linear, then all I got to do is look at my pattern. It's going down by 2 every time. My slope has to be negative 2. It's got to be A or B. And then if I see where x is 0, that's my y-intercept. So that's a pretty simple problem. That my y-intercept is positive 8, my slope is negative 2. This answer has to be A. Alright, 13 says, again, we're going to look at the, instead of the table this time, we're going to look at the graph. I see that this line right here is going uphill, so that's a positive slope. And if I go from one point to another, I have to go up 3 and over 2. My slope is 3 over 2. So right away, it has to be A or B, right? And then I see where the line hits the y-axis. It hits the y-axis at positive 1 right there. So the answer has to be B for that one. 15, they give us a graph, and they say which one of these. Now, this is kind of ambiguous on purpose. They don't want to give you points where you can actually do all the algebra and get the slope-intercept form. They want you to understand y-intercept and slope enough to just look at it and say what it is. So if you look at this where it hits the y-axis, it's right here below 5, higher than 0, and a little past halfway. So my slope is, or my y-intercept is something like 3 or 4, something like that. So I know it has to be B, C, or D. I look again, and my slope is going downhill. It's negative. If it's a negative slope, the only one that has a negative slope and the y-intercept that works has to be D. 16, we have a proportional relationship. Proportional relationships means the equation is y equals mx, which means I need 1 point only, and they give me 1 point. I put the I put the y over the x, and I see my slope is 1/2, so I already have the equation. That's what's nice with proportional relationships. So I have the equation y equals 1/2 x. They say find y when x is negative 3. After I find my equation, I plug in the value for the variable. I plug in negative 3 for x, and I simplify, and I see that y is negative 3 over 2 when x is negative 3 for that linear function. Number 17, they give us a word problem that says a tank was full of water when it was filled. So this is not proportional, right, because we're starting out with something. So no shortcuts here. We got to do the work. When it cracked and water started pouring out, after 12 minutes, there was 220 ounces left in the tank. The set of coordinates is 12, 220. After 12 minutes, there's 220. Time is always x. That's why I put 12, 220, not 220, 12. The other one says the water was all gone after 23 minutes. Well, if the water is all gone, that's 0 ounces. 23 minutes, minutes is time, time is x, so that's 23, 0. So I have two sets of coordinates. That's all I need to write an equation for this. So the question says, how much water was in the tank before it cracked? How much was in the tank means starting point. Starting point means y-intercept. So I take my 2 points. I find my slope. Y minus y over x minus x, you should get a negative. That makes sense because the water is going down. That's why it's a negative slope. So I take my 1 point, it doesn't matter which point, and the slope that I found, and I use y equals mx plus b. I put y here, slope here, x here, just for 1 point, right? I don't mix the 2 points together. And then I solve for b, and b is the answer, 460 ounces. Now, for number 18, they gave us a story problem. They say Gloria drives her daughter to school. Now, if I look on the y-axis, this is not speed, this is distance from home. So if she's driving to school, she's going away from home. That distance is getting greater as she's driving to school. So the answer can't be A. It can't be B either. It has to be, D either. It's got to be B or C. It says she drives her daughter to school, and then she comes back. Well, if I look at B, she drives to school, and as she's coming back, that distance is shortening until she gets back home. The answer has to be B. It couldn't be C. See, C doesn't shorten that distance. All right, 19. We have a right triangle. That means we can use the Pythagorean Theorem to find the missing value. We go a squared plus b squared equals c squared. Remember, the longest side has to be the one that's by itself, right? The longest side has to be the variable, so you can put a c or x there if you want. These two you can get mixed up, it doesn't matter, but you can't mix up the long one. The big side has to be by itself. So I go 3 squared is 9, 4 squared is 16, square root of 25 is 5, that missing side is 5, but if you remember the world famous 3, 4, 5 right triangle, you could have done that without any work. And last problem, number 20, if I look at this, this right triangle this triangle is not a right triangle. It doesn't have 90 degrees, so you can't use the Pythagorean Theorem. And B doesn't work because you don't need all three sides. We just proved that with problem 19. And C and D says, yes, you can, which are wrong. So, hope the video helped.